Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Thank you for coming. My name is Amy Draves, and I'm here to introduce Patrick McCray to the Microsoft Research Visiting Speaker Series. Patrick is here today to discuss his book, The Visioneers: How a Group of Elite Scientists Pursued Space Colonies, Nanotechnologies, and a Limitless Future. It's a tale of visionaries, improbable dreamers whose aspirations for a transformative future helped create the world of today. Patrick McCray is a professor of history at the UC Santa Barbara. He is also the author of Keep Watching the Skies, the story of Operation Moonwatch and the dawn of the space age, and Giant Telescopes, astronomical ambition and the promise of technology. Please join me in giving him a very warm welcome.
Thanks very much. I guess my mic is working. You all can hear me in the back there? Super. Okay. Well, thank you all for coming out. I thank you for coming out in the rain, but I guess that's really nothing unusual here. So the talk I have for you today is to talk about different groups of scientists and engineers and the activities that they were engaged in as they tried to shape their ideas about what the future would be like and its technologies. And the characters that I'll be describing to you today were motivated by a number of things. They desire to explore space, to manipulate atoms, to overcome their inherent biological limits, and to perhaps make a fortune along the way. And the ideas that they had were ones that they believed would offer threats to planetary existential issues such as overpopulation and the overuse of resources, things like that. The talk that I have gives an overview of the story that is presented in the book. And later on, if we have some time in the Q&A, I'm happy to go back over any of the specifics, and we can cover some of those if you'd like. So my talk's about 40 minutes long, so I hope you're prepared for that. But it has lots of visually rich materials, so hopefully that will help carry us through the time we have together. So the book that I've written is about people who were interested in what the technological future would be like. And these were people who also wanted to play a role in helping shape it. And when I wrote this book, there wasn't a good term I was able to find that describes the kind of person whose professional activities I was interested in. I wasn't able to find a term that really defined that. So I developed this term visioneer as kind of a specific kind of actor. So what do I mean by this? First of all, I mean this is someone who has an expansive view of the future. The visioneers that I describe in my book are people that imagine the technologies they're promoting could help shape society in the broadest possible sense, perhaps upsetting traditional economic models along the way. The plans that they had flirted with and sometimes embraced a certain form of technological utopianism. But the people I'm writing about also weren't just content to sit back and do armchair daydreaming. They carried out detailed and extensive engineering and design work in the hopes of seeing their ideas realized. Many of them had advanced university training. They were professors at elite institutions. Some were even had tenure. But in all cases, they had a talent for exploratory engineering and design. And third, in addition to this expansive view of the future and a willingness to apply their technical knowledge to it, they worked to promote and advocate their ideas about the future to a wider audience. This oftentimes required fundraising from some unconventional sources. And sometimes Visioneers' successes attracted other people who were eager to adopt or co-opt their ideas. So it's sort of this neologism between visionary and engineer that I'll be talking about. And to give you some sense of where these people are operating, this is a kind of a crude graph. At the bottom, these are the technologies that we have today, or the kinds of things that are more or less predictable 2 or 3 years out. The kinds of things that can be done with the tools we already have. And at the top, we have the forbidden zone, things that the laws of science say can't be done. So we're not talking about people who are advocating faster than light travel. They're instead operating in this middle space, thinking about what the technological future might be like 15, 20 years from now, working on that sort of horizon. And it's in these spaces of possibility that I'm interested in exploring. So the story that I have in the book starts around 1970. And this is an interesting time because this is around the same time that the future itself was becoming an object of serious study. Economists, scientists, and sociologists were all attempting to understand the future more scientifically, perhaps in order to navigate society towards more desirable futures. So Alvin Toffler's book shown here is one of the best examples of books that came out at this time from this particular futurist genre. But it's these ideas about the future that really got me interested in this project when I started to work on it about 5 years ago. And the future, of course, I'm a history professor. It's somewhat of an odd choice of topics for a historian. I'm supposed to be thinking about the past, not the future. But I was curious about what these past futures were like. And the thing I found most interesting is that we can think about the future not as this neutral space that we move into day by day, year by year, but rather to think about the future as a politically constructed entity, this unstable place that we, as engineers, scientists, as scholars or historians, construct through our texts and our activities, while at the same time marginalizing alternative futures. So not all futures are created equal, in other words, nor is the future neutral. And just two examples here from the red state, blue state idea to give a sense of how politicians have used the future in their own rhetoric and activities. So the characters in my book had a very optimistic view of the future. And this was in marked contrast to what we would have found, say, among the general populace around 1970 when the story starts. This was a time of growing ambivalence and pessimism about technology, hotly debated topics such as what the effects of technology were on American society, debates that were heightened because of the Vietnam War and the escalating nuclear arms race. The late 1960s, of course, was also a time of increased environmental awareness. Popular books such as Paul Ehrlich's Population Bomb presented fears about eco-catastrophism to the American public. Ehrlich's book, for example, warned of the dire effects of continued population growth in the Third World. At the same time, we see the continued use and popularization of metaphors like spaceship Earth, ideas which were made real in photos that were sent back by the Apollo 8 mission on Christmas Eve 1968, showing a fragile blue planet rising above the desolate lunar landscape. And at the same time, there were thoughts about how should the spaceship Earth be managed? Maybe there was a need for tighter controls and restrictions. Perhaps Earth itself should be run like some sort of actual spaceship. And these fears about the future were articulated in 1972 in a most sensational fashion when a group of MIT researchers presented a report called The Limits to Growth. This was a best-selling book. It was translated into some 24 languages and sold millions of copies around the planet. It predicted the collapse of global society sometime in the 21st century, sometime right about now. And the report said that this collapse was inevitable unless governments and economies made a transition from a focus on growth and expansion to some sort of economic and ecological equilibrium. And although scientists and economists roundly criticized its methodology, the Limits report stimulated a fierce global debate about the need to adopt a steady-state economy to regulate population growth and perhaps even curtail individual freedoms. During the 1970s, the idea of limits to technology, resources, energy, political power, became a staple theme among journalists and academics. And these were also picked up among popular culture venues as well, such as movies like Soylent Green or Logan's Run, which some of you perhaps saw in the theaters when they came out. Perhaps some of you have seen it in reruns on television, what have you. But there were some people, however, who refused to accept the concept of limits, technological or otherwise. So in response to these scenarios of future crises, technological enthusiasts, the people that I'm talking about today, proposed alternative and radical solutions to this idea of limits. Now, one of these people was a physicist at Princeton University named Gerard ONeill. He was born in 1927. He served in the US military in the Pacific during World War II, and then after getting out of the military, went to Cornell University and got his PhD in physics before taking a nice plum job at Princeton. Now, O'Neill's specialty was large-scale, high-energy physics projects, similar to the Large Hadron Collider that you've heard so much about this last year. Now, O'Neill's big contribution to this field was re-engineering the way in which particle accelerators were designed, and he was very successful at this. But in the mid-1960s, O'Neill was dissatisfied with where his career was going. He had just gotten divorced, and he was looking for a new path for himself. He tried to make the cut as an astronaut for the Apollo program, and when that didn't work out, he began to look for alternative ways to achieve his dream of exploring space. And O'Neill, starting around 1970, working first with his undergraduate students at Princeton, began to make a case for what he called the humanization of space. And by this, he meant seeing outer space not as a government-run program, but rather as a place in which exploring would not be the province of elite astronauts, but something in which average citizens in the not-so-distant future might be able to do. And O'Neill saw the human expansion into space as a response to the impending threats described in reports like Limits to Growth and the threats of impending environmental collapse. So O'Neill believed space could be a place for extensive human habitation. However, where previous visionaries, and there's a whole raft of people who have talked about space settlements, space exploration, things like that. This is very much staple futurist talk. But where previous visionaries had offered only arm-waving speculations, O'Neill went beyond these fanciful descriptions. He deployed rigorous calculations, informed extrapolations of existing technologies, and developed very detailed designs for his orbiting settlements in space. He backed up his vision of the future, in other words, with extensive physics and engineering calculations, such as examples shown here. His personal papers, which are still in his basement at Princeton, are full of all sorts of calculations and sketches like this. Later on, O'Neill led a series of NASA-sponsored studies that worked out the details of his ideas even further, in which he considered everything from structural engineering issues to the ecological ways in which you would build a closed system habitat to the psychological effects of what living for a long time in space might be like. So one of the models that O'Neill proposed, for example, was a pair of giant rotating paired cylinders in space, about 600 feet long. They would rotate around their long axis to create an artificial Earth-like gravity. And by having strips of both soil and windows, you would have space for agriculture and growing things, as well as windows to let sunlight in. So what O'Neill was in fact designing were miniature spaceship Earths, microcosms of Earth-bound ecological systems. O'Neill, having spent a lot of time in the Bay Area, was a huge fan of coastal California. You can see some of his fondness for that coming out in the drawings and sketches and later the artistic work here, sort of a miniature version of San Francisco, if you will, in space. But one of the technical questions he struggled with was where his hypothetical space colony should be built. He'd already ruled out the surface of the moon or some other planet, too much gravity, while an orbit around the Earth wouldn't provide the necessary gravitational stability. So instead, he opted for a place in space known as a Lagrangian point. There are 5 of these gravitationally stable points in the Earth-Moon-Sun system, and O'Neill chose the one known as L5. Located about 250,000 miles of Earth, it's gravitationally stable, gets lots of free and abundant solar energy. And O'Neill estimated that if the US government put sufficient resources into it, in about a decade or so, the first models of his free-floating space settlements could be occupied. And the cost for the whole project, O'Neill estimated to be somewhere around $30 billion. Now again, this is in 1975 money, so it's a considerable chunk of change, but it's important, and one of the things that this is where historians do so well, is to put it into context. The large mega projects of the 1970s were also running at about this cost level. Things like the Alaskan Pipeline, the Space Shuttle, various nuclear weapons systems like the MX missile were all in the $10 to $50 billion price range. So what O'Neill was proposing was both technically possible and not so economically expensive as to be completely outlandish, which is not the same thing as saying it was either politically or socially viable. So I want to also reiterate a key point that I made. What was novel about O'Neill's conception of this technological future was something he backed up with these detailed designs. But visionaries also translate their ideas into actual things. Sometimes you have to set aside the sketch pad and pick up the welding torch, in other words. So for example, O'Neill worked long and hard to design what he called a mass driver, basically an electromagnetic catapult that could hurl buckets of lunar raw materials from the surface of the moon out into space where they would be caught, processed into silicon and glass and the other raw materials necessary to build a space colony. O'Neill got small grants from NASA To support these ideas, he worked with a group of students at MIT and actually built a working prototype that was featured on the television show Nova in 1978. But visionaries also build communities. So for example, in the mid-1970s, devotees of O'Neill's ideas started something called the L5 Society. The name naturally came from the celestial location that O'Neill proposed for his first space settlements. L5ers gave talks at science fiction conventions. They were part of a growing grassroots pro-space movement that claimed several tens of thousands of members by about 1980. And interestingly enough, they wove interesting environmental themes into their proselytizing as well. The idea that if you truly were an environmentalist, you would get off the planet altogether and move the polluting, overpopulating human societies out into space, leaving the Earth behind as sort of a gigantic nature reserve, if you will. Now, O'Neill wanted to get his ideas out before a larger audience, but it took him more than 2 years of revisions and rejections before he finally managed to get an article published in the magazine Physics Today in 1974. That same year, O'Neill organized a conference on space colonies at Princeton, which got international attention. One of the articles in the New York Times that covered it is shown here. And all of a sudden, O'Neill found himself with a large audience, and a very eager audience for his visioneering ideas. Now, eventually he assembled his designs, his vision for the future, his imaginings about what the future would be like into a book that was published in 1977 called The High Frontier. It was written for a popular audience. It was translated into 8 languages and sold very, very well. In fact, it won Phi Beta Kappa's award for the best science book of 1977 and inspired a whole mini genre of books about space colonies and space settlements. But O'Neill also wanted to have a voice in policy-related discussions. So he frequently testified before Congress about what the U.S.'s future plans for space should be like, how solar energy brought back by satellites beamed down to Earth in the form of microwaves could help make the U.S. more energy dependent, things like that. And again, it's important to put this in historical context. O'Neill's doing this only a few years after the Apollo program had just ended. The last Apollo astronauts went to the moon in 1972, and NASA was looking for its next big mission, the next big thing that it was going to do. And it's not as if Congress or NASA were prepared to fund O'Neill's ideas to the tune of the $30 or $40 billion that he wanted, but NASA did recognize the public enthusiasm that O'Neill's ideas generated. And as a result of the publicity that he received, the visibility that he acquired in Washington, D.C., the fact that he was an esteemed Princeton professor, O'Neill eventually became a minor celebrity. The stack of articles about him in the Princeton archives is about 3 inches thick. So, I mean, he was regularly featured in all sorts of magazines, newspapers around the world. Made appearances on the Johnny Carson show, the Merv Griffin show, 60 Minutes. So millions of Americans, at least for a brief period of time, were aware of his ideas for what the possibilities for space exploration might be. And in the process, this sparked a whole range of debate and discussion. To some, the ideas of living in space seemed a logical extension of the 1960s countercultural lifestyle that wanted to trade urban environments for rural communes. Other people believed O'Neill's visioneering offered pragmatic solutions to social and environmental issues. Other supporters were attracted to fantasies of escapism and the possibility for social experimentation with no authoritarian oversight. But for those who favored a small is beautiful philosophy advocated by people like E.F. Schumacher, space colonies provoked horror and outrage. Opponents saw O'Neill's ideas as simply an extension of the military-industrial complex out into the final frontier and the antithesis of an environmentally responsible technology. And this spectrum of sentiments is captured nicely here in a series of drawings that appeared in a book edited by the publisher of the Whole Earth Catalog, Stuart Brand. So on the one page, we have an illustration of a O'Neill-style space colony, and the happy members of the colony are saying, "Goodbye, Earth." And then paired with this is a 19th century photograph of a Native American couple, one of them saying, "Goodbye, good luck," and the other person saying, "Good riddance," kind of capturing the polarized extreme of views that people had towards O'Neill's ideas. Now, one of the dangers of being a visioneer is that once your ideas are out there and freely circulating, they can be adopted and co-opted by other people. It's very difficult to control the message, in other words. And Gerard ONeill saw this happening with Timothy Leary. In 1970s, the former LSD guru began to promote something he called SMILE, an acronym Leary devised to mean space migration, intelligence increase through various psychotropic drugs, and life extension. There's a great story about Leary at a spaceflight convention, and Leary joking with reporters about being in favor of space migration and about how he and his hippie friends had discovered the high frontier long before Gerard ONeill had done so. This image from a comic shows Leary's own takes on how space colonies would help usher in the next phase of conscious human evolution, and another image showing Leary talking to college students, the same demographic that were also turning on to ONeill's ideas. Sort of an interesting historical irony. Timothy Leary, former Harvard professor, New Age guru, and prison escapee, took his final trip in April 1997 aboard a 55-foot rocket. After he passed away, some of his ashes were shot into space. Interesting enough, that same rocket also carried some ashes from ONeill, who had passed away in 1992, a few years earlier. So despite their obvious differences about how one should perhaps go into space, they were united at least in orbit for a certain period of time. Okay, back to the main story. Enthusiasm for ONeill's ideas reflected a larger shift that was taking place in the United States about technology. New publications like Omni Magazine. Who here remembers Omni Magazine?
When did it stop?
It stopped in 1995. There's a story about that. Ask me in the Q&A. Okay. Magazines like Omni captured this sort of efflorescence of new enthusiasm and ideas that people were having about technology around the time that Ronald Reagan was elected. And of all the topics that Omni presented in its first few years, none received more attention than space exploration. It still was the next frontier. Almost every issue mentioned ONeill, space colonies, the grassroots pro-space movement. Sentiments were captured nicely on this button that Omni circulated. The meek will inherit the earth. The rest of us will go to the stars. Now, of course, the future turned out quite differently, of course. Omni's readers didn't go into outer space, but instead they turned to new technological frontiers, and that takes us to the second part of our story. As I said, many college students were drawn to ONeill's ideas for the humanization of space, and one of these was an MIT undergraduate named Eric Drexler, shown here in the audience in 1978, at the same time that ONeill was testifying before Congress. A space enthusiast, Drexler soon turned his attentions to a new and different technological frontier. Drexler was born in 1954, so he's about 3 decades younger than ONeill. Grew up in Corvallis, Oregon, and at a young age displayed a strong affinity for science and engineering. And like ONeill, the teenage Drexler responded sharply to the idea of limits and this general pessimism about technology that pervaded the 1970s. Drexler goes to MIT. As I said, he gets deeply involved in the pro-space movement. In fact, many of the people who first expressed interest in what eventually becomes known as nanotechnology had some connection in some form to the grassroots pro-space movement of the 1970s. Anyway, Drexler stays on at MIT after finishing his undergrad degree, and he begins to think about what it might be possible if you could manipulate materials at the molecular level and build machines and other devices. Now, he's not coming up with these ideas out of the blue. In fact, there are 2 main technological developments that were influential on his thinking. One of these you all are familiar with, the steady progress in miniaturization that was happening in microelectronics and the computer industries throughout the 1970s. First PCs hit the market in the mid-1970s. About the same time, the journalists began talking about this thing called Moore's Law. The second influence on Drexler's thinking was the developments that were happening in molecular biology. In the 1970s, science developed the capability of splicing genes from one organism to another, what we now know as recombinant DNA technology. And this ability stirred interest in the possibility of designing new proteins and other biomolecules that weren't naturally found, but things that could do useful tasks. So it was common for science writers and scientists themselves to talk about bacteria and other biomolecules as tiny factories, which could churn out useful products. And Drexler takes these 2 streams of thought and brings them together, and he publishes a first expression of his ideas in 1981. It kind of gives a general overview of his thoughts, where he describes concepts for what he calls molecular engineering, where he imagines nanoscale machines directed by computer code, much in the same way as RNA transmits instructions to our ribosomes to make new proteins. Drexler described machines that could precisely put molecules where engineers wanted and build up nanoscale devices atom by atom. Now, Drexler named these general-purpose machines assemblers. Now, you all will recognize this as a term for a program to convert code into language that the machine can understand. And this is a kind of an important strain of thought because Drexler was immersing himself deeply in artificial intelligence work that was being done at MIT at this time. He became a protege of Martin Minsky, for example, for a couple years. Drexler imagined that his molecular machines would also be able to self-replicate, much in the same way as our cells do. And biology provided inspiration as well as proof of concept for him. Now, there was nothing in the scientific literature that said building these things was impossible. And Drexler became convinced that because these things could be built, it was quite likely, perhaps even inevitable, that they would be built. So instead of presenting his ideas as scientific research, he begins to describe them using the term exploratory engineering, much in the same way as early rocket pioneers in the 1920s designed engines on paper that could work in theory, that obeyed the laws of physics, but that they couldn't quite yet build because they didn't have the adequate materials. In 1985, Drexler and his wife, Christine Peterson, a chemical engineer, pick up stakes, leave Cambridge, Massachusetts, and relocate in Silicon Valley. There they establish a nonprofit organization called the Foresight Institute. And the term nanotechnology becomes something that Drexler begins to use increasingly in his talks and his articles around 1985. Drexler saw himself not as an advocate for nanotech, but rather as someone who was trying to promote a greater understanding of it, both in terms of what it could do, but also in terms of any perils that it might pose. And drawing upon connections that he built up in the Bay Area, Drexler and Peterson began to expand Foresight's membership. Now, coming back to the point I made earlier, visionaries build things. But when it came to nanotech, Drexler's design and construction took place inside a computer. He and his associates used various computer modeling tools that were available in the late 80s, early 90s, different software programs to design molecular machines in silico that in theory obeyed laws of chemical bonding and physics. They weren't things that chemists could actually build yet, but they were things that at least in theory seemed possible to build. Now, this approach to nanotechnology was not appreciated by all scientists. This wasn't real chemistry or real physics. And here we see an interesting tension beginning to develop between the chemist's view of what can we do in the lab today and how does this work, sort of a probing of nature, versus Drexler's exploratory engineering, which asked, what might we be able to build tomorrow? But again, recall, Drexler isn't presenting himself as a scientist. He's not interested in understanding nature as it exists today, or the today back then, but rather as someone who's exploring the boundaries of engineering, of probing what might be possible. And then throughout the late 1980s, Drexler's ideas get increasing amounts of international attention. He publishes a book called Engines of Creation in 1986, which articulates his ideas, written not for a community of scientists, but rather for a popular audience. Engines of Creation offers a very expansive view of the technological future, talking about all the interesting things that might be possible in the future when we have increased artificial intelligence, self-replicating machines, future space exploration plans, so on and so forth. And it sells very well. About 100,000 copies are sold internationally. It's translated into many languages. So his ideas are out there and are circulating rather widely by about 1990. But it's interesting to ask, who were some of the people who were first interested in this early form of nanotechnology? Now, a key group of supporters actually came from the computer science and software programming community, as well as the entrepreneurs who had become rich in those industries during some of the boom years of the 1980s and 1990s. Now, of course, cybernetics, artificial intelligence, and direct computer control all figured prominently in the Drexlerian vision of nanotechnology. And also, early nanotechnology, at least from an organizational point of view, was being done in the same garage culture style that we associate with Silicon Valley entrepreneurship. But this wasn't about building new products. Instead, it was about promoting a particular vision of what the future would be like. So one of the explanations for why people from the comp sci community were interested in this Drexlerian vision was stated here in an interview that I did with Christine Peterson a few years ago. Basically saying that computer engineers were people who were quite comfortable about manipulating digital bits, quite comfortable working on that scale, and it wasn't difficult for them to imagine transferring that control, the ability to work at that scale, and the particular philosophy about how technology would change into actual material objects. Recall that these are people with a business model based on discontinuous technological change. Predictions about nanotechnology seem to follow the success dictated by Moore's law, where every so often a new development would come along out of the computer science community and shatter the prevailing technological paradigm. So sort of interesting to see that just as Drexler's own ideas are heavily based on computer modeling and simulation, the support that he's initially getting, both in terms of the people who come to meetings, who join the Foresight Institute, but also the people who are giving money to support his activities, are largely coming out of the computer engineering and software community, not the chemistry community. Now, if you weren't a computer programmer or a software engineer, one of the ways that you would have heard about Drexler's ideas would be through popular science magazines, things like Omni, for example, which in 1986 ran the first sort of full-length article that described early ideas for nanotechnology. This Drexlerian vision of the nano future got considerable attention. Some might even say it got too much attention. And there were scores of articles that followed on this. Nanotechnology also became a regular feature of dozens and dozens of science fiction, television shows, novels, things like that. So for example, Star Trek in 1989 features nanotechnology as sort of a key plot device, for example. So by the mid-1990s, nanotechnology, this term that was originally promoted and popularized by Drexler, begins to attract increasing interest from the scientific mainstream. Nanotechnology also started to gain currency among policymakers in Washington, D.C. Now, one of the reasons for this attraction was the fact that the Cold War was coming to an end. And there were hopes among policymakers that nanotechnology might become an overarching area of scientific research that could bring funding back to areas of science, areas like physics and chemistry and computer science, that had been left behind as government support was directed more towards the life sciences and biomedical research in the 1990s. Also, at the end of the Cold War, economic competitiveness, rather than competing with the Soviets, had become a much more central concern. Nanotechnology was imagined as a stimulant for the 21st century economy, much in the same way as IT had spurred the US economy in the 1990s. Experts estimated, for example, that nanotech would mean millions of new jobs in this country and would form the basis for a $1 trillion sector of the global economy by the early 21st century. But the problem, however, is that by the time we get to the mid-1990s, there are two different flavors of nanotechnology. Which nanotech are they actually talking about? Was it the kind of research that was marked by discoveries such as new forms of carbon like buckyballs or nanotubes, as well as new instrumentation that allowed scientists to move atoms around one by one? Work that was done, for example, at IBM's Almaden laboratory in San Jose to take scanning tunneling microscopes and move xenon atoms around and spell out the IBM logo, for example. So this is the kind of work that Thomas Kuhn in the Structure of Scientific Revolutions would have described as normal science, or the day-to-day laboratory activities. Or maybe nanotechnology meant this radical view of the technological future that would be enabled by these nanoscale machines that Drexler and his growing community of supporters proposed. The problem for mainstream scientists was that reporters often conflated these two things and presented this radical view of nanotechnology to the public as what the future was going to be. In other words, when the average technology enthusiast or politician thought of nanotech, they thought of self-replicating nanoscale assemblers. This was a far cry from the normal day-to-day research that was being done in labs at universities and corporations all around the world. And this identity crisis was made all the more urgent by the fact that nanotechnology was developing in the minds of many scientists a public image problem. Drexler's visioneering, despite his professed intent, was having a profound impact on shaping the public perception of nanotech. A couple examples shown here. Bill Joy's famous 2000 article in Wired magazine called Why the Future Doesn't Need Us, proposes actual moratorium on nanotechnology research out of fears that self-replicating nanobots would escape their laboratory confines and get out into the ecosystem and wreak havoc. We see in 2002 the publication of Michael Crichton's best-selling book Prey, which is based on a dystopian future in which nanobots escape a corporate/government-run laboratory and again wreak havoc. And then interestingly, we have this image also from the same period here in the middle that was proliferated widely and copied and oftentimes reproduced in articles about nanotechnology. And it's not quite sure what's happening here. Is this nanobot saving the red blood cell by injecting some sort of healing medication into it, or is it attacking and killing it? It's ambiguous, it's hard to say. But again, if the average person is imagining nanotech, it's this that they are starting to think about. And the result is that mainstream scientists worked very, very hard in the late 1990s to disentangle their research from these Drexlerian ideas for nanotechnology. They worked assiduously to marginalize Drexler, to marginalize the people who were advocating his ideas, and to really set up boundaries between what was being done in the laboratories here and now versus what might be possible in the future. Such that in December of 2003, when President George Bush signs the 21st Century Nanotech RD Act, which results in billions of federal dollars pouring into nano research, if we look at the people who are standing behind Bush, we see a cabinet member, we see a Nobel Prize winner, we see a venture capitalist, I think we see a couple senators here and there. But what we don't see is the person, the economist, labeled the godfather of nanotechnology, Eric Drexler. By the time the federal government has fully gotten on board the nano bandwagon and is investing, last time I checked, I think the budget for nanotech research this year is about $1.8 billion. Drexler had been effectively marginalized. By 2003, nanotech had become the next big thing, but it was being done very differently than Drexler and his supporters had advocated and imagined. So some concluding thoughts. Now, a cynic might say that all of this history is interesting, but ultimately pointless. After all, we don't have space colonies now, we don't have nanobots. In other words, these visioneers and their projections of the future were failures. Now, I don't entirely agree with that. I think it's important for people to come forward with big ideas, and visioneers help define the outer edge of what's possible. Their ideas help push people's thinking about what the future might be like and what its technologies might be like. So, sure, the future didn't unfold as Drexler or O'Neill had imagined, but their visions did capture and shape public imagination and stimulated lots of productive dialogue between politicians and scientists and business leaders. At the very least, their visioneering got people interested in talking about and debating the technological future. And in fact, portraying their visioneering as failures because their futures went unrealized underestimates what their visioneering actually did accomplish. So we can find, for example, examples of Drexler's influence in some mainstream nanotechnology work today. Now recall that his initial vision was very biological in nature. It started with designing protein machines that would be able to manipulate groups of atoms and form the basis for other nanoscale devices. I was intrigued to see just a few weeks ago an article in Nature in which a team of British researchers announced they had done a series of research that was inspired by biological ribosomes, and they had built in their laboratory nano machines, their term, not mine, which can pluck amino acids and move it down the axle of their machine and basically assemble a brand new peptide polymer. Now, according to Nature, these molecular machines are inspired by biology and will eventually enable chemists to build materials with a very specific sequence of molecules. Again, very much a Drexlerian vision of research, although not framed in quite the same way as he had framed it 30 years ago. Or another place we might see the influence of these ideas is in what today we call sort of AltSpace or space exploration 2.0. Recall that O'Neill imagined space not as this massive government-run program, but as a place. And part of this meant access to space for people other than astronauts. This meant also encouraging the creation of smaller and more agile firms that would take people and cargo into space. And I think we're seeing this today in some of the activities of some of the space startup companies, companies like SpaceX, firms like that. At the same time, though, there are some flaws in visionaries' thinking. Oftentimes, they are looking for the single get-out-of-jail-free card that will allow them to circumvent all limits, sort of the one-size-fits-all technological solution to a variety of societal problems, sort of an attempt to get a grand slam home run rather than chipping away at the problem by hitting a bunch of singles and sacrifice flies. So I'd like to end with two analogies. One of them is that today business executives commonly use ecological terms to describe the places where innovation happens. Regional ecosystems like Seattle, or ecosystems centered around particular products. And these ecosystems are home to familiar species, companies, universities, researchers such as yourselves, entrepreneurs, funding agencies. Visionaries are also part of that ecosystem, and their influence at times was disproportionate to the numbers and resources that they had. In big and small ways, visionaries have helped alter the innovation ecosystem. This isn't to say that we wouldn't have tens of thousands of scientists today working on nanotechnology if Eric Drexler had never been born. But I think it would be called something different, perhaps. Its history would certainly be different, and it might exist as a more fragmented research agenda. Drexler's visioneering helped give it shape and form, at least for a period of time. Now, but to be sure, visionaries' ideas displayed a utopian streak. But historically, utopian movements have always been a source of radical new ideas. And visionaries are no different. Their ideas about the future are rarely adopted as a complete package, but the ensemble that they present is something that can be unpacked and pulled apart, examined more closely so that scientists, engineers, the public, and policymakers can selectively sample and choose from them. One of the ways I like to think about the visionaries is that there's sort of a form of dark matter surrounding a more visible galaxy of research that's done by mainstream scientists and engineers. Their research and promotion, existing often on the threshold of outright respectability and academic visibility, still exerts a certain gravitational pull on the public's imagination of what the future would be like. So I started my talk back in 1972 with the Limits to Growth report. And in 1972 and today, many similarities. Planetary threats from climate change, threats from overpopulation, these all resemble the same existential dangers that Limits to Growth warned us about 4 decades ago. In fact, my story starts actually in the book with Jerry Brown as governor of California. And hey, Jerry Brown, he's again governor of California. It's a nice symmetry. So at the same time today, we have advocates of geoengineering, synthetic biology, and other emerging technologies that have their designs for the future. So I think it's important to pay attention to visionaries then, why and how their activities succeeded, and when and how they didn't. Because the future, after all, is where we are going to spend the rest of our lives. And technologies are the tools that we use to consciously construct this future. And ultimately, the choice between the future we want and the one we make is ours. Thanks very much. I don't know how you all do things here. Just fire questions or whatever works for you. Yeah?
What happened to Omni?
Okay. Omni Magazine was started by Bob Guccione and Kathy Keaton. Bob Guccione and Kathy Keaton made their money from the softcore pornography magazine Penthouse, and they did very well with that, and they were keenly interested in the technological future and all things technology and paranormal-like, so that's where the money for Omni came from. Bob Guccione also had a very expensive art hobby. He collected millions of dollars worth of art. And something called the internet happened, and that pretty much put Penthouse out of business, because why pay for porn when you can, yeah, I think you see where I'm going with that. So the end result was the funding that was being used to support Omni Magazine dried up, and the print edition went away in the mid-1990s. They tried an online version for a while, and that didn't work out terribly well. And they also didn't really keep pace with the times. If you look at an issue of Omni from 1979 and one from 1992, it's sort of like they didn't realize that the world had changed. It was the same font, it was the same style, it was the same kind of cartoons and stuff, and they just didn't really, oddly enough, move with the future. Hi.
You didn't mention Drexler's, I think, other key influence. I mean, I read Engine of Creation. I believe the always room at the bottom paper was one of his things too.
Yeah.
I mean, rather important actually, because claiming it was actually not impossible where
Yeah.
they came from.
I didn't mention it just for time limits, but no, you're right. Richard Feynman's 1959 paper, there's plenty of room at the bottom. You know, a talk that Feynman gives in 1959 makes a splash when it first comes out, gets buried in the literature. You never hear of it again until it's rediscovered around 1980, in part by Drexler, and then it's really rediscovered in the 1990s by policymakers, because as they're promoting nanotech, what better rhetorical source to draw upon than a Nobel laureate, Richard Feynman, sort of the iconoclastic, crazy physicist, who's also dead by this point. So he could be used in any sorts of variety of ways, and he wasn't actually there to argue and say, that's actually not what I meant. I wouldn't put Feynman in the same category, though, as my visioneers, in part because while Feynman proposes these ideas, he doesn't do anything with them. He gets the Nobel Prize for his work on quantum electrodynamics. He doesn't actually do any nanotech work. So he sort of lays out a vision, but he doesn't then follow up with it in the same ways.
I wouldn't call him an engineer, just he was key to Drexler.
Oh, totally.
Enabling Drexler.
Absolutely. I completely agree. Yeah.
Have you spent any time thinking back centuries into visioneers potentially centuries ago? And you started off with an author, I think.
Yeah.
Yeah.
I haven't gone back centuries. I've gone back maybe, well, how about 2 centuries? How about that? So, who are other people I would put in this category? Nikola Tesla, Charles Babbage and Ada Lovelace, Wernher von Braun in his pre-Nazi days. Von Braun, sort of caught up in the German, spaceflight movement of the 1920s and 1930s before it gets militarized, had very expansive visions about what our future in space would be like. Other people have shown here, Elon Musk, Ray Kurzweil, certainly, Doug Engelbart and his ideas for sort of the office of the future, I think. Ted Nelson, I think, would also fit in this category of sort of imagining kind of the future of what hypertext would do, although he had a very idiosyncratic view of what that would be like as well.
You would, in general, it sounds like you would exclude just people who were authors.
Like Jules Verne.
Jules Verne, right.
Yeah, I would. Because I think, and again, this is a term that I've created, and I've kind of drawn my own box around it. But I think it's important, as I'm thinking about it, to differentiate between the people who just simply offered the speculations and the people who offered the vision and the speculation, but also rolled up their sleeves and tried to do something with it. And in some ways, sometimes those efforts didn't go anywhere. Sometimes in Drexler's case, they were just computer simulations. But it's sort of that willingness to apply engineering and physical practices that sort of separate them from kind of the arm-waving futurist of, it's going to be like the Jetsons, et cetera, and so forth. Which we could say something about flying cars if you want, but maybe that's a topic for another thing. But I have a great story about flying cars. Other thoughts? Yeah.
What would you say in today's world are some of the visionaries or visioners of the future, and especially in light of just what you mentioned with the Jetsons, because the social, there's so much access to technology and imagination through that.
Probably the person that fits my definition the best these days is probably Elon Musk. And I know Musk is a controversial character and a whole slew of issues around that. But that's the person that comes to mind the most for me. But the flying car thing is interesting, and since I brought it up, I feel like at least I can't just leave you out there teasing with a story about, I'll tell you a funny story about flying cars. About 2 months ago at UC Santa Barbara, we had a visitor from Silicon Valley, someone who works for the Singularity University, and sort of a technology pundit sort of person. And kind of gave this very gee whiz, again, sort of a hand waving about what the future would be like, and he kept referring to his iPhone, like, look what the iPhone can do, look what the, things that we've all heard before. And then he was sort of drawing upon that slide that I showed, drawing his own version of it, this one here, sort of a snarky way of thinking about this. We were promised flying cars, but all we got was Twitter, basically. And my response to this was, and I think this is a key point that the visioneers in my story miss, was the reality is we have flying cars. We've actually had flying cars since the 1930s. I mean, the first ones flew in the 1930s. Henry Ford invested a considerable amount of money to build flying cars. The reason we don't have them is not because they're technically impossible. We don't have them because of social reasons. We don't have them because of laws and regulations and safety issues and those sorts of messy social and political reasons. And I think this is a key point that the visionaries in my story, who are far from perfect, that they miss. That it's not enough to simply have a good technical idea, but you also need to consider the broader, what the NSF would like to call broader impacts and social implications aspect of it. You just simply can't put these ideas out there and just because that they are technically sound, assume that they will be acted upon, that there's more required to do it than that. The same with O'Neill. He designed bulletproof designs for space colonies. They met all the necessary technical requirements, but he never really addressed the pressing social and economic and political issues. For example, how would you persuade the American government in the wake of Vietnam, in the wake of a recession, in the wake of the oil crises of the 1970s, to invest this much money? And the reality was, and is, if you truly are concerned about overpopulation and overuse of resources on this planet, there are better ways to address that than by building space colonies. There are laws and regulations and policies that could be enacted. But oftentimes, like I said, the people in my story are kind of looking for the grand slam home run rather than the small base hits that will move their agenda forward. Yeah?
Are there any patterns among the visionaries in the book around their extreme dedication and how that might impact their personal lives?
Around the what?
Their extreme dedication or passion to their area.
That's a great question. The pattern that I've noticed, and this is something that disturbs me a little bit, is the pattern that I see isn't so much how it affects their personal life, but the pattern is that the people that I'm writing about and the people who are attracted to their ideas are all very much from a similar demographic. They are white, male, elite educated, you can fill in the blanks there. The women in my story are largely supporting characters. They are the wives, the people who are helping bring these visions along. And I don't have an explanation for that. I don't know why there aren't more people of color who are doing these sorts of activities. It's something that I bring up in the conclusion of the book, but it's a very unsatisfying thing for me because I don't have the answer to that. It's just I can observe this, but maybe it's a function of, I'm primarily a US historian. I'm looking primarily within the borders of this country. That might be part of it also. But I guess also what I find interesting is that the appeal of O'Neill and Drexler's ideas, even though their books were translated into many languages, again, is still largely within this country. And I think that probably says a great deal about American character in terms of how we think about progress as a nation, how we think about technological enthusiasm in this country, and how we see technology and changes in technology as a path to national betterment. And I think that's probably a larger pattern. I know it's not quite the direction that you were headed in, but that's the thing that I notice.
You also say that nano is here, showing up here in all kinds of little areas.
Yeah, no pun intended.
Not intended.
Okay. I think I'm supposed to wrap it up now. I'm getting the hook. So thank you all very much for coming out, and I appreciate you taking the time out of your workday. Thanks a lot.